Welcome to the channel, everyone. Today, we're diving deep into the world of machine learning. If you've ever wondered how AI really works, how your phone seems to know what you're thinking, or how self-driving cars are even a thing, this is the video for you. We're talking about the tech behind the scenes that's changing how we live, work, and play. It's a lot to cover, but don't worry, we're breaking it down step by step so you can really get it. From the different types of machine learning and how they work to the algorithms that make it all tick, we'll explore the tools, the applications, and even the challenges that come with this powerful technology. Plus, we'll look ahead at what the future holds for ML. Let's get started. First things first, let's unpack the different ways machines actually learn. Think of it like this. There's supervised learning, where we give the machine a bunch of labeled data, like pictures of cats and dogs, and tell it which is which. It's basically learning with a teacher. Then there's unsupervised learning, where the machine is on its own to find patterns in unlabeled data. Imagine giving it a ton of photos without saying what they are. It has to figure out the structure and relationships itself. And of course, there's a blend called semi-supervised learning, and even reinforcement learning, where the machine learns by trial and error. Like mastering a video game, each type has its own strengths and is used for different things. Now, before we go any further, let's talk about some key terms you'll hear everywhere in the world of machine learning. We're talking about features, which are like the characteristics or variables the machine uses to understand data. Then there are labels, which are the answers we want the machine to predict. And of course, there's training data, the massive data sets used to teach these algorithms. We also have to talk about testing data, which is how we see how well the machine learned. Oh, and don't forget about overfitting, underfitting, cross-validation. All crucial for making sure our ML models are accurate and reliable. All right, let's talk algorithms. These are the mathematical recipes that power machine learning. One of the most basic is linear regression, which is used to predict a continuous value, like the price of a house. Then there's logistic regression, used for classification, like figuring out if an email is spam or not. But it gets way more interesting. We have decision trees, which break down decisions into a tree-like structure, and random forests, which combine multiple decision trees for even more accuracy. And then there's the big leagues. Neural networks inspired by the human brain are used for everything from image recognition to natural language processing. And let's not forget about K-nearest neighbors, a simple but powerful algorithm for classification and regression. Chapter 4, Applications of Machine Learning, ML in Action. So, how is machine learning actually used? Well, it's everywhere. Take natural language processing, or NLP. This is what powers chatbots, language translation, and even those smart assistants we talk to. Then there's computer vision, which allows machines to see and interpret images. Think self-driving cars, medical imaging, and facial recognition. But it goes way beyond that. Machine learning is behind those eerily accurate recommendations you get on Netflix and Spotify. It's optimizing delivery routes for companies like Amazon, and it's even helping doctors diagnose diseases earlier and more accurately. The possibilities are really endless. Chapter 5, Tools and Frameworks for Machine Learning, your ML Toolkit. Now, if you're ready to get your hands dirty with machine learning, you need the right tools. Python is the go-to programming language, with libraries like scikit-learn for general-purpose machine learning tasks. But for deep learning, you'll want to check out TensorFlow and Keras, developed by Google, or PyTorch, which is popular in the research community. And of course, there are platforms like Google Colab and Amazon SageMaker that provide cloud-based environments for running your ML experiments. Chapter 6, Challenges in Machine Learning, the Roadblocks. Now, machine learning isn't without its challenges. One of the biggest is data quality. If you feed a machine bad data, you're going to get bad results. It's like that old saying, garbage in, garbage out. Another challenge is bias. If the data used to train an algorithm is biased, the algorithm itself will be biased, and that can lead to unfair or even harmful outcomes. And then there's interpretability. Some ML models are so complex that it's hard to understand why they make the decisions they do. Chapter 7, Future Trends in Machine Learning, the Next Frontier. So what's next for machine learning? Well, one exciting area is explainable AI or XAI. This is all about making AI more transparent and understandable so we can trust its decisions more. Another trend is federated learning, which allows ML models to be trained on decentralized data like on your phone without compromising privacy. And then there's AutoML, which aims to automate the process of building ML models, making it accessible to even more people. The future of machine learning is incredibly exciting. Outro, the future is now. That was a crash course in the world of machine learning. We covered the different types, the key concepts, the algorithms that make it all work, and even the challenges and future trends. If you're as fascinated by this technology as I am, hit that like button and subscribe to the channel for more deep dives into the world of tech. And be sure to let me know in the comments what you're most excited about in the world of machine learning. Until next time.